In this lesson, we're going to work on proving lines are parallel based off of their corresponding angles, their alternate interior angles, their alternate exterior angles, or the consecutive interior angles, which are sometimes called same-side interior angles. Before we get to there, I want us to think back to what we did in Chapter 1 of copying an angle. So that's the first thing I'm going to do, and I'd like you to try this too. It might be a little difficult, I guess, at home, being you may not have a compass, but I want you to watch it and see how that we copy this angle again. So remember, the first thing that you do to copy your angle is you're going to want to make one side of your new angle. So there I have the one side of my new angle. Now the next thing that we need to do is we need to get our compass out. Now remember, what we need to do is we need to put the point of the compass on the vertex of the original angle, and then open up your compass, and it doesn't really matter how far, and then make an arc that goes across both sides. Now take that compass and don't change the measurement on it. Put the point of the compass at the vertex of the new angle, or what's going to be the vertex of the new angle, and then make that same arc. Make it nice and big because we don't know where the other side is right now. Then come back here, put the point of the compass at one of those intersection points, and put the pencil at the other intersection point to measure how far it is from intersection point to intersection point. Now I have that here. I'm going to take this compass, I'm going to bring it back here. I'm going to put the point of the compass on the one intersection point that I have, and I'm going to work on creating the other one. And let's just change the color here. Let's go purple. And once you have this, make this arc, and it should cross your original arc another time. So you get an intersection point here. Now you can come and you can make your other side of your ray, or other side of your angle, which will be a ray. So from the vertex, put your straight edge, and then through that point, make it, and we have constructed an angle congruent to the original one. And the reason we want to do that is because now here I'm going to use my compass and the straight edge, and I want you to make a line, which I've already done in the red, make another line that's eventually going to become the transversal that I've done in blue. I put a point on my what's going to be the transversal in the purple, and now what I want to do is I want to copy, and I don't care which angle you pick. I'm going to pick this angle, and I'm going to copy it down here so it will become a corresponding angle. So I want to copy it into this area. I'm going to make this same angle somewhere in here using those same steps I did before. What's nice here is I don't have to make that original ray because it's already here. Here's the vertex of my new angle, here's the ray. So step one is done. Now I just need to get that compass out, and I need to do what I did last time of put the point of the compass on my original vertex. I need to make an arc, and I'm going to change the color to this pretty pink and make that arc cross both sides of the angle. Come down to my new vertex and make that arc so it's going to cross both sides of the angle, and you don't know where that's at yet, so just make it nice and big. Then go back to that original angle, put the point of the compass there, get the, oh look at that, it lined up just perfect. So I didn't even have to move mine. Most of the times you're going to have to move that so that the point is here and the pencil's there. And then bring this down. Remember, put the point of the compass where that arc intersects your ray, and then make another ray, or make that another arc that will cross the first arc. There we go. Now I just want to move this out of the way. And now you can make your line or ray go through the vertex and through that point. And when you look at these, mine isn't perfect, but if you were to be able to be perfect with it, you're going to notice that these two lines are going to appear to be parallel. So what I want us to look at is what just happened there. I took an angle up here, I copied it down here so that they're corresponding angles. So I created corresponding angles that were congruent, but in the process of doing that, it also created two lines that were parallel. So I think about this. If corresponding angles are congruent, well then what do I know about the lines? Well, they're going to be parallel. So I come back here and I have if corresponding angles are congruent, what do we know? We're going to know that the lines are parallel. Now this next one says if the alternate interior angles are congruent, what are we going to know? Well, I'm going to bring us back here. Well, really, you could look at this of, yeah, I know I took this angle and copied it down here, but we know that vertical angles are congruent. So really, I could think of it as, I took this angle here and I copied it down here. So I made alternate interior angles be congruent, which made my lines parallel. So here, I'm going to delete what's here, and you're going to notice it says, well, then the lines are parallel. Now I can go, if alternate exterior angles are congruent, well, what are we going to know? And again, I'm going to come back here. And I'm going to look at it, yep, I took this angle up here, and I copied it here. Well, let me extend this ray the other way. So if I go this way with it, I could think of it as, instead of copying the angle to here, I really copied it right here, because these are vertical angles. So now when I look at it, I took an angle up here, copied it here, they're alternate exterior angles. So I can think, if the alternate exterior angles are congruent, well, then the lines are, yep, you guessed it, they are going to be parallel. And then my last one, if the consecutive interior angles are supplementary, well, again, I'm going to come back here, and I want us to think about this. Again, I took this angle and I copied it to here. But now what I want to think about is, I know these two angles, this one and this one, oops, these two angles are supplementary because they form a linear pair. These two angles are supplementary because they form a linear pair. And now I have this angle supplementary to this one supplementary to this one. So if angles are supplementary to congruent angles, then they're congruent, which tells me that this angle and this angle are congruent. But again, if these are supplementary and these are supplementary, well, then these two are also going to have to be supplementary. So you can think about it as, I created consecutive interior angles to be supplementary, and in the process of doing that, I made parallel lines. So my last one here, if consecutive interior angles are supplementary, well, then the lines are parallel. And some of you are thinking right now that, well, I've seen all these before. Kind of, but not really. If you go back to lesson 3.2, we had all of these statements the other way. And when I say that, I mean this is the converse of a statement we already had that said, if lines are parallel, then the corresponding angles are congruent. So we have a situation where the conditional from lesson 3.2 was true, and its converse now from this lesson is true. So technically we could take the two, put them together, and write a biconditional. For all four of these statements, that will work. It works both ways. If the lines are parallel, you know corresponding angles are congruent. And vice versa, if the corresponding angles are congruent, then your lines are going to be parallel. And these are the four real important statements that you need to know based off of this lesson. Keep this in your head, and I will have another lesson based off of some examples from these four statements.